for whoever doesn't know, is a distributed computing project run from here at RPI. It works on things related to the structure of the Milky Way. There are actually two Milky Way homes, which I'll sort of talk about. The first one works on finding tidal streams, and tidal streams are, well, the Milky Way has all these like dwarf galaxies orbiting it, and they're getting torn apart by the much larger Milky Way, and they get turned to these tidal streams of stars that loop around the galaxy a lot of times. There's also the second application, which does n-body simulations, which I know more about because I pretty much wrote it. So this is basically what the first thing does, is it takes a sample of data from the SDSS and it tries to pick out tidal streams from wedges of the sky. So this is, I'm not exactly sure what set of results this is, but this is, the red dots are like picking out exactly where the stream is because they twist around and they're like contortion type things. I don't know. It tries to find the streams with some kind of statistical something or other. The n-body simulation does this. I'm not actually sure how this was produced since there isn't actually code to support this. But so I'm just not going to question where this actually came from. But it basically does things like this. It creates a dwarf somewhere and then orbits it and then rips it apart and compares it to observed streams. So what we did, as mentioned last week, what we did was we have Milky Way at home for iPhone. It works on jailbroken iOS 4 devices. And you can see here's the icon and a sample of the amazing interface. So it's sort of real. The actual separation thing is what actually runs. If given a real work unit and enough time, it will actually finish. Although I estimate it will take about 2 weeks. It picks one of 5 random work units that I put on the internet special for it, and it downloads them. They're 1,000 times smaller than normal, but they take about 10 seconds to run on my desktop. They take about 20 minutes on my iPhone 3G and use 8% of the battery. It then takes the results and puts them in the body of an email to milkywayforios@gmail.com, where you can send me the results, because the BOINC libraries don't work. So far, 143 people have sent me results. Some people have sent many. One person sent about 10, I think. I'm still getting some. You get it from Peter City repository, so I think some people are looking for Mobile Notifier and finding it. Peter sent me this video, somebody reviewing Mobile Notifier, and in the video he says, there's also this Milky Way utility, I haven't checked it out yet, it's new, or something like to that effect. The other person emailed me asking, Milky Way, what is it? What can I do with it? And someone else said, I don't know what this is for, something, please update Mobile Notifier. During my last presentation, I forgot to mention my actual primary goal for the semester, although I haven't actually started that yet, so that's okay. I'll get to that at the end. So the main thing I've been working on for many months now is there's this ATI application, which is where 85% of our results are coming from, which was written by some random guy in Germany, and we never got the source for it, even though he said he was going to give it. And now he just ignores emails, so I've needed to rewrite it. So I was using ATI's OpenCL, I guess AMD now, but they were really bad at software, and I gave up on using their OpenCL, so I switched to using the lower level Cal and this scary thing called Cal++, which is written by some crazy Polish guy, which I talked about before. It uses like horrifying like thousands of lines of C++ templates and stuff, and it generates code. It's like terrifying. So the reason I used this was to make it as fast as the current ATI one, because people won't like it if they're getting less credits because the thing is slower. If people are really into the BOINC credits, I don't understand. But for a long time, there was like a 2 or 3 month period where I was like, I don't know why this isn't as fast. It turns out it was as fast, and I had the wrong number in my head for like performance goal. I'm really dumb. But the main like integral, which takes the actual time, is as fast. But I haven't done the likelihood at the end, which just adds a few seconds, so it doesn't actually matter that much. Although people will complain about that because it's like 4%, because it takes about 70 to 80 seconds, I think, on a 6970, and then a few seconds people will notice, I guess. I also need to test this on something besides 5870. I had a 4870 for the 4000 series testing. However, if I run anything on it for more than about 10 seconds, it overheats and my system shuts down. So I haven't tested that. I also don't have a 6000 or a 3000 series to test it on. So what I've been doing this week is I completely destroyed the server the other night. I wanted to make 2 small changes to the scheduler, and I emailed some people to try to get that applied. And then they're like, oh, why don't you update the whole server? So then I did, and it just went to hell. So right now it's running SVN trunk, and everything is at least partially broken. It's slowly getting better. I'm not sure what the current status is. It's probably broken. But also yesterday, or I guess the day before, what was formerly known as the API Stream SDK, they're getting rid of the API brand. AMD is, since they own them now, and they're gradually rebranding everything. So they get rid of the Stream name, so now it's the Accelerated Parallel Processing SDK or whatever. So this is the AMD APP SDK, which is a triple acronym. And the release notes I really love, because I read this. In the next version, they plan to deprecate Cal. I'm so glad I spent like forever working on that. And then just because they're really bad at software, there are always things like this. This is not the first time there have been notes like this. Double precision built-in functions can produce incorrect results on GPU X. So, so besides that, that was delayed for a while because one night I randomly decided it would be cool to embed Lua. And because we wanted to, I was told they wanted to have these different like models, and they were like debating which ones they wanted for multi-component models and things for like dark matter and stuff, more complicated things. And to generalize everything that might want to happen, it was just too complicated to do with like the boring static JSON configuration I had before. So then I ripped it all out and replaced it with Lua. So now you can have a totally arbitrary initial body distribution, and it's a little bit less gross. It also allowed the potential for much better in-body tests, which I've done some work on. So the build system has gotten slightly better, at least on Windows, because I'm not really sure how to get it to work on Windows. I just sort of do sometimes, because usually when I try to get things like this, GPL program for Windows NT 2000 XP Vista and Windows 95 98 ME has stopped working when I try to build things sometimes. I'm not convinced there are any compilers or like any kind of way to get a functioning build environment on Windows, so I just sort of hope things work sometimes. So the main thing I wanted to accomplish this semester was I need to get the n-body simulation running on GPUs. The plain O of n squared one is the canonical GPU programming example, but that's the O of n squared one, which is not what we're doing. The n-log-n Barnes-Hut version is a lot more complicated to do on GPUs. There are I found some papers on this. There's more stuff since last time I looked over the summer, but there are a lot of useless papers that aren't worth the bandwidth I spent to download them because there's no code available. There's like very high-level descriptions of what they did that aren't like useful. So like one of the groups I found, I emailed the authors and they said the code is proprietary. So they have these results about their code and how great it is and how fast it is and everything, and it's completely worthless. I don't understand why this is allowed to be like published because there's no way I can verify the results or anything about what they're doing. They could just be making nonsense up. But I did eventually find a starting point that is much better than some of the other stuff I found because it copies, it's like almost exact clone of the same Barnes-Hut tree thing. Because others I was finding were talking about like slightly different kinds of trees they use and things like that. And we want totally consistent results across GPUs and systems, and with the CPU one, that would be ideal. So questions?
So where do they publish those papers? Is Astrophysical Journal or?
There have been a bunch of papers on the separation stuff for the n-body. There was one that was accepted to some IEEE thing in Alaska for, I don't know what it is. Then there was somebody's PhD thesis, the n-body.
So usually if you ask the students who are the authors of the paper, usually they oblige with code and data and so on. So they do ask us about sending the data, sending the code. We do. Good job.
Matt?
Yeah. Colin.
Have you seen they have like a JavaScript distributed thing? So you can like turn the observatory webpage into like folding your Milkyway. Like just force people to use their computation.
I have not.